Hello guys and welcome at my channel. It's been a while since I've been doing it last time, but now let's start it over again. Well, today I would like to explain some basic ideas about differential equations. So what is a differential equation generally? Well, you see, in the high school you've been looking for special x values like x squared equals to 5 and you've been solving it. So the equation of x squared was perfectly already known. Now the situation is slightly different. You don't know the function, but you know the momentary rate of the function and the connection between the momentary rate of a function to the function itself. For example, let's check y prime equals to y. So y prime equals to y. It's a differential equation that we're solving. And what is the approach? Well, the approach is we are rewriting y prime as dy over dx equals to y. We then divide by y, assuming it's not 0. By the way, 0 would be the only function besides e to the power of x, which is going to be the solution in a few moments, that is satisfying this equation. But obviously, f of x equals to 0 is not a nice one, so we would like to move further and to find an interesting one, which is the Euler's function e to the power of x. And since many students know what is the Euler's function or the E number like 2.718 and so on. It's great, but they do not know that much about Euler himself and his contributions to science and to mathematics especially. So I highly recommend you to maybe find 10-15 minutes, check some Wikipedia links, or maybe buy a book if you wish. I would just write me an email. I would recommend you some. There are so many great books about Leonhard Euler, one of the most efficient and, craziest mathematicians in history of humankind, I would say. So I think, like, my favorites are Gauss, Euler, and Isaac Newton, maybe. Yeah, but there is also Omar Khayyam and Leo da Vinci, so there are so many great guys. Okay, let's come back to differential equations. We divide by y and we multiply also by dx. All right, so what we're going to have is dy divided by y equals to dx. And now what we're doing, so the thing about calculus is now we have momentary rates of change and they're equal like everywhere. So if the momentary rates of change are equal everywhere, we can also add them up. And this is going to be still the same result. So what we're going to do now, we're going to integrate both hand sides. If you remember, this is some pushed letter of S. Leibniz introduced it. And so we're going to have integral 1 divided by y dy, as you can see right here, equals to integral of dx. I hope you're familiar with a little bit of calculus, with the basic ideas. If not, I hope I'm going to find some time and do some introductions also about calculus. Well, number theory would be great as well, but let's stick to this example. So what we have so far is ln of y, the absolute value, because on the left-hand side the negative values are also allowed, but in logarithm only positive values are allowed. Maybe you know why. If it's not the case, then think about the exponential function as a to the power of x and try to think which values are allowed for the base a. And you will see that the base of a is bigger than 0 and not equal to 1. So this is the reason why we only take positive values. I think I have one of the videos on my channel about logarithms, so maybe you can check it as well. But maybe I'm going to upgrade them as well. So it equals to, this is kind of 1 times dx, so the original function of 1 is x, and since we're talking about non-definite integrals, we also add a constant c. So ln is the same as logarithm to the base of e, so we would have y itself equals to e to the power of x plus c, as you can see. And now we can rewrite it using the power rules, which you also can find on my channel. This is e to the power of x times e to the power of c, and e to the power of c, this is a constant, which you also can call k. So the answer is k times e to the power of x. And this is the easiest differential equation solved, totally. Like whatever function, like 5 times e to the power of x, or 27, or 35,544, whatever number you take, it's always the same derivative as the function itself. Okay, let's give me an example. Let's give you an example once again. So let's say y is 5 times e to the power of x. If I'm looking for the derivative of this one, I'm going to find the derivative of the whole expression, and we call it a factor. So the factor rule of the derivatives of the differential equation allows me to take it out. So I only have the derivative of e to the power of x, which is e to the power of x. As you know, once again, I hope I'm gonna make a video with the whole proof. So this is the easiest differential equation totally solved, which shows you there are only two functions in this whole universe, like y equals to 0, obviously 0, derivative of 0 is 0, and the second one is k, some constant value, times e to the power of x. Okay, I hope you liked it. Thanks for watching, and see you guys next time. Bye bye.